building upon the example we had before, what we want to do now is to estimate the slope between 2 points. Well, if we think about this, what we want to think about as the slope is this number right here tells us the sales that we get if advertising equals point A. And what this tells us is the sales we should get when advertising equals B. And now what we want to do, rather, is here is point A, and here is point B. And so to find the slope of this line is just like we did when y equals mx plus b, is we want to think of this as the change in y over the change in x. Well, what is the change in y over the change in x? Well, the change of y is the sales of point B minus the sales of point A divided by B minus A. So it's the change of x in the bottom and the change in the sales of x, or of y rather, in the numerator. And so this will tell us the slope. We call this a secant. So a secant is a slope, is the line that connects any 2 points on a function. Now, while this is correct, we're going to rewrite it in a little more technical term, which we're going to be able to build upon later. We say the slope of the secant is equal to f of x2 minus f of x1 all over x2 minus x1. So here b is x2 and a is x1, so we see how they relate. F of x2 is just the sales of point B, and f of x1 is just the sales at point A. And what this is saying is simply just it's the change in y over the change in x. And what the secant tells us is the average rate of change between any 2 points.